What we've built isn't just a powerful observatory, it's a time machine. The telescope's unparalleled precision allowed it to capture light from the earliest moments of the universe. And with each image, a deeper mystery unfolds. Before the Big Bang, it was believed there was nothing, no matter, no time, no space. But what came just before? That's where the questions grow deeper. Our galaxy, the Milky Way, is just one of around 2 trillion others scattered across the observable universe. They emerged from the primordial chaos, tiny islands of stars and dust stretching across unimaginable distances. The idea that all of this stemmed from a singular origin was once revolutionary. Now, it seems almost quaint. In 1965, researchers detected the faint afterglow of the Big Bang, what we call the cosmic microwave background. It was a silent confirmation that something massive had occurred billions of years ago. But even that discovery, groundbreaking as it was, didn't answer the biggest question: why did it happen? The latest telescope findings might not offer a full answer either, but they push the mystery further. The analogy often used is that of an expanding pie. Imagine the raisins as galaxies, being carried apart as the dough rises. But unlike a pie with edges, the universe has no clear boundary. It isn't expanding into anything, it's simply expanding, creating its own space as it grows. During the early inflationary phase, the vacuum of space was filled with a strange kind of energy that grew proportionally with volume. As the universe expanded, this energy didn't thin out, it intensified. Then, almost at random, it began dissipating, triggering the conversion of energy into matter. This chaotic, brilliant moment birthed what we now call the Big Bang. And yet, according to quantum theory, even this could have emerged from what we perceive as nothing. A spark, a ripple in the vacuum, may have been all it took. This possibility opens up the concept of a multiverse, countless bubble universes forming and expanding independently. Ours might just be one of many. Even so, the Big Bang theory is not without its flaws. It doesn't explain everything. For instance, if gravity alone shaped the galaxies, they would have taken far longer to form than they actually did. That's where dark matter enters the conversation. It's invisible and undetectable by ordinary means, yet it exerts gravity and forms scaffolding upon which galaxies are built. Scientists believe there's about 6 times more dark matter than visible matter, helping to speed up galaxy formation in the early universe. In 1998, a separate revelation shook astrophysics once again. The universe's expansion wasn't slowing down, it was accelerating. This was the opposite of what gravitational models had predicted. Something was pushing everything apart, an unknown force we now call dark energy. It's not just filling space, it's stretching it. And as we try to understand this cosmic acceleration, more adjustments to the Big Bang model are necessary. Why is the temperature of the universe so uniform across such vast distances? How did light from the early universe travel far enough to smooth things out? These puzzles led scientists to propose the idea that the universe began even smaller than previously thought and underwent an extraordinary burst of inflation in its first split second. That would explain how distant regions could have once been close enough to share heat and information. The telescope's job is to gather light that's been traveling across space for billions of years, from the very first stars and galaxies. On Christmas Day in 2021, it began that mission. And what it sent back has been extraordinary. It captured images of galaxies formed just a few 100 million years after the Big Bang. It has shown us star-forming regions never seen before, dense clouds of gas and dust where new solar systems are being born. In a stellar nursery called NGC 346, located in the Small Magellanic Cloud about 200,000 light-years away, the telescope revealed something even more unexpected. Scientists had thought this region was relatively free of dust, the kind of material needed for star and planet formation. But the data showed dense, complex dust structures, suggesting that stars, and possibly planets, are forming faster than ever imagined. This is important because NGC 346 mirrors conditions from what astronomers call cosmic noon, a period billions of years ago when the universe was rapidly creating stars. Observing it allows researchers to glimpse how early galaxies might have functioned. And if planets like Earth could form in such dusty, ancient clouds, it changes our estimates about when life-sustaining worlds could have first appeared in the universe. Even more shocking were recent detections of massive galaxies existing just 500 to 700 million years after the Big Bang. Current models didn't predict galaxies of that size could have formed so early. Either star formation was far more efficient than we thought, or there's a flaw in how we interpret the data. Some of these objects might even be hiding supermassive black holes, adding another layer of complexity. And this is just the beginning. The telescope has been operational for a short time, yet it has already disrupted decades of scientific consensus. It's giving us direct access to the infancy of the cosmos and forcing a re-evaluation of how stars, galaxies, and planets form. Most of the universe is invisible. The majority of its mass is dark. Its energy, mysterious. But with every new observation, we peel back another layer. What lies beyond may be stranger than any theory we've imagined. As we gaze into the abyss, searching for our origins, we must also accept that the universe is not obligated to make sense to us. It existed long before we tried to explain it and will continue long after. But with instruments like this telescope, we inch closer to the truth, even if that truth is unsettling. Perhaps the universe was not created for us to understand it fully. Perhaps it simply invites us to try. Just after the Big Bang, when stars and galaxies first began to take shape, a revolutionary telescope that had been under development for 25 years emerged to help us understand the early universe. Known as the James Webb Space Telescope, or JWST, this powerful instrument is considered the successor to the Hubble Space Telescope. With capabilities said to be 10 billion times more powerful, the JWST has transformed our ability to see deep into space and far back in time. Since its launch, it has delivered some of the most stunning images ever captured, showing galaxies that formed just a few 100 million years after the Big Bang, and even moments before stars were born. Among its many remarkable achievements, the telescope took the first direct image of an exoplanet orbiting a distant star. It has also explored regions like the Tarantula Nebula, a nursery for young stars previously hidden from human eyes. One of its most fascinating discoveries is an image of NGC 346, part of the Small Magellanic Cloud, a dwarf galaxy roughly 200,000 light-years away from Earth. NGC 346, already known as a stellar nursery, provides a rare and detailed view of conditions during what astronomers call cosmic noon, a time when star formation was occurring at a much faster rate. Contrary to earlier beliefs that star-forming regions lacked dust, JWST scans have revealed vast amounts of stellar dust in NGC 346, which seems to play a vital role in accelerating star formation. Margaret Meeksner, the lead scientist behind the study, explains that NGC 346 is the only major cluster in its galaxy currently producing stars. This gives researchers a unique opportunity to study what the universe was like during one of its most active periods. The presence of metallic dust swirls also hints at the possibility of planet formation in addition to star birth. This could mean that Earth-like planets may have started forming much earlier than previously thought. Despite having been in orbit for just over a year, the JWST has already surpassed expectations. Its discoveries not only highlight the telescope's advanced design and instrumentation but also offer invaluable glimpses into the history and structure of the cosmos. Its infrared capabilities allow it to see wavelengths of light that are invisible to the human eye. As a result, the telescope can detect the faint glow of ancient stars and galaxies, effectively looking back in time, up to 13.5 billion years. Among the most surprising findings so far is the detection of 6 enormous galaxies that existed between 500 and 700 million years after the Big Bang. These galaxies are much larger than what existing models of galaxy formation would predict. This forces scientists to reconsider how galaxies were born and how they evolved. The earlier assumption that galaxies started as small clouds of stars and dust that slowly grew over time may no longer hold true. While researchers are still verifying the exact nature of the objects detected, it's possible that some of them could be hidden supermassive black holes rather than galaxies. Regardless, the presence of so much mass in the early universe is a major shift in our understanding. Even if future findings reduce the sizes of these objects slightly, the data already suggest that star formation might have been far more efficient than previously imagined. This could mean that JWST is interpreting some young, bright stars as older than they actually are, leading to revolutionary insights about the early cosmos. The journey into the ancient universe is just beginning, and the James Webb Space Telescope is proving to be the most important tool we have in unraveling its secrets. With every image it beams back, it challenges what we thought we knew and opens a new window into a universe that still has many mysteries to unfold.